Hello and welcome. So, descriptive geometry, more importantly, auxiliary views. What exactly are those to drafting? Well, descriptive geometry is a branch of geometry which allows the representation of three-dimensional objects in two dimensions by using specific sets of different procedures and methods. So, should sound pretty similar. I mean, that's what drafting is. Drafting is descriptive geometry. Probably what you came here for, though, is auxiliary views. Now, auxiliary views are pretty easy to find in a 3D CAD system. We can just take our models or our assemblies, rotate them around, and find the correct view that we want to look at. Not so much in a 2D application. So something like AutoCAD, like you see on the screen. So an auxiliary view, by definition, is a projection on an auxiliary plane that is parallel to an inclined or slanting surface. It is a view looking directly at the inclined surface in a direction perpendicular to it. Auxiliary projections are important for describing the true geometric shape of inclined surfaces. So that is a mouthful, but that is the probably the most used and technical definition of what an aux view is. Essentially, we use them to show non-basic orthographic views. So our six principal views are front, back, top, bottom, left, right. Those are our six principal views. Anything that is not in one of those principal views that we need to view at its true size or true shape, we create an auxiliary view for. So that is what we're going to look at today. Now here I've got two parts. I've got two wedged shaped blocks, one with a hole, one without. So we're going to take a look at the one on the right here, the one without the hole. And if we wanted to find this particular surface and wanted to find its true size or its true shape, there's a way that we can create it. So right now you see I've got some phantom lines between my views. Those are strictly there for a reference point for us to use when we create our construction lines. But essentially what we're doing is we're taking the points from one view and translating them to another view. We're making it perpendicular to where that particular surface is at an incline, or where we see that particular surface as an edge. So looking at this part, we know that this big slanted edge here, that surface is foreshortened. If I look in the top view, I don't get my true length. It's foreshortened because it's angled. When I look down at it from the top, I can't see the actual length of it. That's where auxiliary views come in. So essentially what I'm going to do, like I said, is take the points of that, translate it to my front view, and then again translate that to an auxiliary view. So what I've done here is I've created another phantom line that I'm using as a fold line that is parallel to this surface. Again, where I see it as an edge. Now, next thing I want to do is make sure that my points actually line up. So if I go straight down, we can see my points there, all line up. That's important because if your views aren't lining up, you can't create these. Okay, and let's switch to a different layer real quick. So in my construction layer 2 here, next thing I want to do, I want to go in and I'm going to make perpendicular reference lines from my edge to my fold line. This helps me make sure that everything is aligned whenever I prepare to make the actual auxiliary view itself. And I'm going to quickly delete these to get them out of the way. So, how do we get our points from top view to front view? It's really quite simple. I'm going to, again, switch to another layer. Let's go to 6 here. And we're going to create a quick circle here. So essentially, whenever I'm looking at my inclined surface that I want to make an auxiliary for, I want to make sure that I'm aware of every single point on that surface. That's what my little reference construction circles here are representing. I have 4 points on this particular plane, and pretty easy to tell just by looking at it. Then what we can do is we can go in, and there's a couple different ways we can do this. We can go in and we can measure from said point back to our reference line. Helps if I actually get the dimension command going here. There we go. So I can dimension to it, find the distance it is away from my reference line, and then replicate that distance off of my fold line I've created down here. Now for your distance from edge to fold line, doesn't really matter. Again, it's just a reference point. I think I've set it at ½ an inch to be away from my edge here. You can do 1 inch, 12 inches, whatever. It really doesn't matter. It is just a reference point. But like I was saying, we can go in and take our dimensions to each of those points back to the reference line, and then come down here and offset or draw lines out to those specific distances that are perpendicular to our edge. Now, a somewhat easier method that I like to use is I will go in and I'll just use construction lines. We can easily manipulate construction lines and rotate them around, copy them. So what I tend to do is I'll go to my point, draw a construction line down, trim it back to my fold line there, and then I have my distance without having to draw a dimension and then do a whole lot of extra work. So I'm going to do the same thing again for my point up here. And what I do from this point on is I'm going to use those construction lines to set up my points for my auxiliary view. So I'm going to go ahead, copy these two. And again, it's important to follow your lines and your points. So if I'm coming straight down, I hit my point here, follow out that perpendicular line to my fold line, that's where I place it. Now, these points are going to be the same distance away. It's a rectangular part, so I'm just going to copy this here as well. Actually, you know what? Let's hold off. What I can do from here, I can go in and then rotate those construction lines and get them perpendicular to my reference line right here. So I'm going to rotate, use my point here. Now, in AutoCAD, see how we have that orange dotted line? That is our rotational reference line. What we need to do is we need to change that because we want our reference line to go in line with our construction lines that we're rotating. You can see this one right now is set at a 90-degree difference. So if you need to change this, all you have to do is hit R, enter while you're still in that rotate command. Go in, select your reference points. I am going to select my base point here, and then you can kind of see how it's now creating that reference line. I'm just going to go to the back here. Now, whenever I rotate it, you see my reference line is actually in line with my construction lines. Now I can just go and click my endpoint here, boom, they're now collinear. And as I was saying before, since these points are the same distance away, I can go in and copy them over. Now, all we're doing is playing connect the dots at this point. So what I'm going to do though, I'm going to go in and I'm going to copy my reference point here and show you that we have a point there, point there, point there, and our point there. So you can see my 4 points, my 4 points. And like I mentioned before, now we're just connecting the dots. So I'm going to go in again, go down to my solution layer here, and I'm just going to connect my dots. Now I have the actual true size and true shape of my inclined surface that I was looking for. Pretty neat, huh? We can essentially use this same method with any slanted surface. This allows us to just find the points, get their distances from that reference line that we create, and then translate them to where they are coming into the edge view of that surface perpendicular. So now if I needed to find the true length of this, or if I needed to find the area of this surface, I can easily do that. One trick that I like to use is just use the hatch command. Oop. That was not my hatch command. There we go. And let's switch that over to the hatch layer real quick. There we go. What that does is I can then use the properties of my hatch to figure out wanted to be stubborn for him. There we go. And let's bring those down here. What that allows me to do is find my area of my hatch. So in this case, it's giving me the entire surface area of that auxiliary view. So 3.4608 inches. That is known as a primary auxiliary. So we're taking an auxiliary view of one of our principal views, either that being the top, the front, the right side, left side, back, bottom, doesn't matter. If we're taking an auxiliary view off of one of those principal views, that is a primary auxiliary. Then from there, if we do an auxiliary of an auxiliary, that's known as a secondary auxiliary. And then anything past that is known as a tertiary auxiliary. So we can get into a very complex process if we're looking at some oblique type parts that might have an angled surface that's moving in 2 different angles or 2 different directions. So it is possible to find that stuff. But in this video, we're just going to focus on primary auxiliaries. Now, we might come into a problem or a scenario where we might have a surface that is slanted that has a hole on it. In that case, we're doing the exact same thing. We're finding our points, translating those points down to where we see it as an edge view, so in our front view here. And then again, following that same method. There is a way that we can cheat with these curved surfaces though, and that's by using an ellipse command. But from here, let's go ahead and just go through that process. So again, first thing I'm going to do, I am going to come up here, go in, make sure that my points are lining up. They're lining up beautifully. So I'm going to go ahead delete those, don't need those anymore. Then I'm going to go in to my points here, trim those back to my reference line, and again, I am really not going to worry about this other side. Those points are going to be the same, but if I wanted to, I'd do the same process, grab an endpoint, and create my line going down for both of those. I'm going to quickly swap my layer. Again, I'm going to make these perpendicular guidelines, or guide rails, essentially. Come down here. And the interesting thing on this one, I am going to add in one for my center point, and also for the two edges. Oh, hello. That might be a problem. Let's fix that real quick. So let's extend this one out. Then trim this one back. There we go. Check our center line here. Perfect. Okay. Now, going back in here, grab that, grab that. Okay. Double check those just to be sure. Perfect. So anytime we have a cutout, a hole, anything that breaks up that surface of the auxiliary, we want to be sure and account for it on our auxiliary view. So now, what I'm going to do, I'm going to go in, I'm going to find the center of my hole here. Oh, switch back to my first construction there. Find the center of my hole. And I'm also going to grab my edge point here and one of the edge points there. So essentially what I'm doing is I am getting my center point for my particular hole here. I'm also getting the X and Y of the ellipse in case I need it, in case this does not come out to be a perfect hole. But that way I can create the correct size shape. Alright, so I'm going to go ahead, I'm going to copy these here. Again, make sure you follow your lines, your points, make sure that they are matching up. Gonna go here, rotate this guy around. Again, reference line is at a 90 degree to it. I'm gonna fix that by hitting R, enter. There we are. And since I know those points are the same, I'm gonna copy this over to my points down here. And I'm gonna come back over here and borrow our point identifier. I always do this just to help out because you can get a lot of construction lines going at one time, so having a circle or even just a point somewhere on there, that can definitely help you out. Okay, now what I'm going to do is I'm going to grab my pieces here, and I apologize, it is now starting to rain pretty heavy outside, and imagine you can probably hear that in the background, so we'll just pretend that it is soothing background music. But from here, I'm going to copy my center point, again following it down, bringing it out to that fold line, and I am going to rotate both of those from my base point there. Again, changing the reference line, and you'll notice whenever I rotate those, even though they're lined up here, they don't quite match up exactly. So that is an example of how things are foreshortened in angular views. So this is very important. This is why we do this, because if we try and throw a dimension on some of these features that are foreshortened or skewed, we're going to come up with wrong dimensions. So this is a good example of why we do this. But since I know this should be here, I am just going to move my construction line right over there. Alright, now let's copy our reference points again, or reference circles, over to our different points. So if you notice here, we can kind of make out the outline of our part now. We're also got the center point in our XY coordinates essentially, or the quadrants of that hole. And I'm just going to go in with my solution layer and start filling some of this in. And it helps if I hit the actual point. Ah, there we go. There and there. So there's that. Now, looking at this, I'm fairly confident that this right here is going to be an actual hole, just because we're seeing an ellipse in this view. If we look at our points here, pretty obvious that they are equidistant from the center. So let's test out that theory. If I go in with my circle command, come up here and go to the endpoint there. If I look, oh yeah, that is an actual circle. So we have a perfect bolt hole going through our piece there. Now, on something like this, you can kind of tell we're getting a lot of lines on here. If we need to check our surface area, I can quickly just grab these, go over here, make a copy, switch over to my hatch layer, switch over to hatch, and hatch that, and there you go. Gives me my cumulative area of my part right there. Now, with this auxiliary view, I can go in and give a proper dimension to that bolt hole. Oh, come on. Alright, it's on to be stubborn. Let's go up here to our power dimension then. Grab the radius. There we go. Perfect. So now we can see we have a 1/2 inch diameter hole on the surface of this part, or in this case going all the way through the part. Can't really tell that it's a 1/2 inch in that view, right? So again, this is showing the importance of those auxiliary views. So this was just a quick rundown of the primary auxiliary views. There's probably going to be a secondary auxiliary view coming as well, just to prepare us for that, as well as getting into other concepts of what we call descriptive geometry. Like I said, 3D CAD systems make this pretty seamless, pretty painless, not so much in the 2D setting. So we'll continue to explore descriptive geometry in this video series. But for now, as always, be inventive.